Okay. Hi, welcome to the Excel for Statistics course. By the end of the course, you will be able to perform basic business statistic analysis using Microsoft Excel. Then through this course, you will also learn some of the benefits of using Microsoft Excel for daily needs, which will help you to be able to perform better at your job and your business. Let me share the course material first for you. So here we go. So for now, we will learn about the Excel statistical functions. And the functions we will learn now are gamma, gamma distributions, gamma inverse, gamma ln precise, Gauss, or log norm distributions, normal distributions, normal inverse, normal standard distributions, and then normal standard inverse. And all of these functions are distribution and test of probability function. So for the first function, we will learn about the gamma function. So gamma function is a function used to return the gamma function value. A function used to return the gamma function value. The syntax of the function is equal gamma, open the bracket, number, close the bracket. Number returns a number and it is required. So for the example, right now, we have number and the data is 1.2. You can put it into your Excel first. You can pause the video and after that you can play the video again. Okay, so I hope you already put the example, the argument and data example in your Microsoft Excel. And then right now we will try to do the gamma function. So we type the gamma and then the number is 1.2. Okay, so the results of the 1.2, the data 1.2 is 0.91816874. Okay, so how about we change the data into 2.5? And then the result is 1.32934039. So this is the gamma result from 2.5. And then the next function, gamma distribution. So gamma distribution is a function used to return the gamma distribution. The syntax of the function is equal gamma distribution, open the bracket, x, alpha, beta, cumulative, close the bracket. Ex is the value at which you want to evaluate the distributions and it is required. And then for the alpha is a parameter to the distribution and it is required too. And for the beta is a parameter to the distribution. If beta equal to 1, the gamma distributions returns the standard gamma distribution. And then it is required too. And then for the cumulative, is a logical value that determines the form of the function. If cumulative is true, gamma distribution returns the cumulative distribution function. If false, it returns the probability density functions. So for the example, we have this data set. You can type this data set first in your Microsoft Excel. You can pause the video, and after you finish it, you can play this video again. Okay, so I hope you already finished your data set. And then for the X, we have 9.2 in here. For the alpha, we have 8 in here. And then for the beta, we have 1 in here. And then for the cumulative, we have false. Okay, let us try to do the gamma distribution function. We type gamma is, open the bracket, put the X, put the alpha, put the beta, and put the cumulative. And then the result of gamma distribution function for this data set is 0.111833. Okay, so this is the result of the gamma distribution function. But how about we change it into px into maybe 10.5, and then for the alpha 9, and then for beta 2, and then it's true. Okay, so for this data set, the gamma distribution results is 0.08594143. Okay, so this is the gamma distribution function. And then the next one is gamma inverse function. Gamma inverse function is a function used to return the inverse of the gamma cumulative distribution. A function used to return the inverse of the gamma cumulative distribution. The syntax of the function is equal gamma inverse, open the bracket, probability, alpha, beta, close the bracket. The probability is the probability associated with the gamma distribution, and it is required. And for the alpha is a parameter to the distribution, and it is required too. And for the beta is a parameter to the distribution. If beta equal to 1, gamma distribution returns the standard gamma distribution, and it is required too. We have this kind of data set. You can type this data set first into your Microsoft Excel. You can pause the video, and after you finish it, you can play this video again. Okay, so for X, we have 0.025. For the alpha, we have 8. For the beta, we have 1. So let's do the gamma dot inverse function. Put the X here, put the 8, and put the 1. The result is 3.4538322. So this is the result of gamma inverse function for this data set. But how about we change it into 0.5, 9, and the beta is 2. The result of gamma inverse function is 17.337902. Okay, and then we move to the next function. We have gamma function. Gamma function is a function used to return the natural logarithm of the gamma function. A function used to return the natural logarithm of the gamma function. The syntax of the function is equal gamma ln, open the bracket, x, close the bracket. X is the value for which you want to calculate the gamma ln, and it is required. So for the X in here, we have 3. You can put it into your Microsoft Excel first and pause the video, and after that you can play this video again. Okay, so we will try to do the gamma ln function. We type the gamma ln. Okay, open the bracket, put the x, close the bracket, and then the result is 0.693147. How about we change it into 5.5? The result of the gamelan is 3.957814. So this is the result of gamelan function for the 5.5. And then for the next function, we will learn about gamelan precise. Gamelan precise is a function used to return the natural logarithm of the gamma function. A function used to return the natural logarithm of the gamma function. Okay, the syntax of the function is equal gamelan precise, open the bracket, x, close the bracket. X is the value for which you want to calculate the gamelan precise. It is required. Okay, so for the example, we have argument in here. So for the argument is x, and for the data is 3. Okay, and now we will learn to do the gamelan precise function. Okay, open the bracket, put the x in here, and then close the bracket, and then the result, oh, I'm sorry, gamelan precise, I'm sorry, this one, not this one. Okay, I'm sorry, because I type 0 instead of typing close bracket, and then I just type 0. And then the result for gamelan precise for 3 is 0.69314718. How about we change the data into 5.5? The results for the gamelan precise is 3.9578139.7. So this is the gamelan precise function for the results for the 5.5. And then the next function is Gauss. Okay, Gauss is a function used to calculate the probability that a member of a standard normal population will fall between the mean and standard deviations from the mean. Okay, so the Gauss is a function used to calculate the probability that a member of standard normal population will fall between the mean and the standard deviation from the mean. The syntax of the function is equal Gauss, open the bracket, x, close the bracket. X is the value you want to use to calculate the Gauss function, and it is required. For the example, we have x for the argument and 1.5 for the data. You can put it into your Excel first, you can pause the video, and then you can play this video again. Okay, so let's try to do the Gauss function. Equal Gauss, open the bracket, put the x on here, and then the result is 0.433192.8. So this is the result of the Gauss function for the 1.5. How about we put the 0.25? The Gauss function changes into 0.0987063. So this is the Gauss function. Okay, and then we move to the chord function. Okay, chord function is a function used to return the cortices of a data set. The syntax of the function is equal chord number 1, number 2, and so on, and close the bracket. Okay, so the chord function is a function used to return the kurtosis of a dataset. For number 1, number 2, and so on, is the number 1 is required. Subsequent numbers are optional. Okay, so the number includes 1 to 255 arguments for which you want to calculate the kurtosis. Okay, so we have this data set. You can type the data set first into your Microsoft Excel. You can pause the video, and after that, you can play this video again. Okay, so we have 2, 5, 8, 3, 5, 7, 3, 4 in here. So let's do the chord function. Type the chord. Okay, put the data right here. Okay, so the result of the chord from this data set is minus 0.6990074. So this is the result of the chord function from this data set. Once again, this function is used to return the kurtosis of a data set. Okay, how about we change it into 1, 4, 7, 9, 4, 3, 6, 3. And then the chord function will change into minus 0.017252. Okay, and then the next function is log normal distributions. Okay, so log normal distributions is a function used to return the log normal distribution of x, where ln x is normally distributed with parameters mean and standard deviation. The syntax of the function is equal log norm distribution, open the bracket, x, mean, standard deviation, and cumulative, close the bracket. Okay, so log norm distribution is a function used to return the log normal distribution of x, where ln x is normally distributed with parameters mean and standard deviation. X is the value at which to evaluate the function. Mean is the mean of ln x. Standard deviation is the standard deviation of ln x. For the cumulative is a logical value that determines the form of the function. If cumulative is true, log norm distribution returns the cumulative distribution function. If false, it returns the probability density function. And then for this dataset, we have this dataset. You can type this dataset first into your Microsoft Excel. You can pause the video, and after that, you can play this video again. Okay, so we already finished your dataset. So we have 3 for the x, 2.5 for the mean, 1 for standard deviation, and 2 for the cumulative. Let's do the log norm distribution function. Put the x, put the mean, put the standard deviation, and put the cumulative. So the result of the log norm distribution function from this dataset is 0.0805491. So this is the log norm distribution function. And then we have normal distribution. Okay, sorry. Okay, normal distribution is a function used to return the normal distribution for the specified mean and standard deviation. The syntax of the function is equal normal distribution, open the bracket, x, mean, standard deviation, and cumulative, close the bracket. X is the value at which to evaluate the function. Mean is the arithmetic mean of the distribution. Standard deviation is the standard deviation of the distribution. For the cumulative, is a logical value that determines the form of the function. If cumulative is true, normal distribution returns the cumulative distribution function. If false, it returns the probability density. Okay. For the example, we have this data set. You can put the data set first, and after that, you can pause the video, and after that, after you finish that, you can play this video again. Okay, I hope you've already finished your data set. For the X, we have 32, mean 30, standard deviation is 1, and then cumulative is true. Okay, let's do the normal distribution. Okay, normal distribution, open the bracket, put the X, put the mean, put standard deviation, and put true. Close the bracket, and the result is 0.97724,987. So this is the result of the normal distribution function for this data set. And then the normal inverse function. Normal inverse function is a function used to return the inverse of the normal cumulative distribution for the specified mean and standard deviation. The syntax of the function is equal normal inverse, open the bracket, probability, mean, standard deviation, close the bracket. Probability is a probability corresponding to the normal distribution. It is required. For the mean is the arithmetic mean of the distribution. It is required. And then for the standard deviation is the standard deviation of the distribution, and it is required too. So for the example, we have X, mean, and standard deviation in here. So for the X is 0.9772499. And then for the mean, we have 30. And then for standard deviation, we have 1. Okay, let's do the normal inverse function. So for the X, we put the X in here, put the mean, and put the standard deviation. And then the result is 32.000006. This is the result of normal inverse function for this data set. Then normal standard distribution is a function to return the standard normal distribution, which has a mean of 0 and a standard deviation of 1. And then the syntax of the function is equal norm as distribution, open the bracket, set cumulative, close the bracket. Set is the value for which you want the distribution. For the cumulative is the I'm sorry. Okay, so this is the correct. I'm sorry. Okay, so the cumulative is a logical value that determines the form of the function. If cumulative is true, norms, normal standard distribution returns the cumulative distribution function. If false, it returns the probability mass function. So we have 1.2 for the C value and then true for the cumulative. So let's do the norm standard distribution function. Put C in here and then put true in here. And then the result is 0.88493033. This is the normal standard distribution for this data set. And then the last one is normal standard inverse function. It's a function used to return the inverse of standard normal cumulative distribution. The syntax of the function is equal normal standard inverse, open the bracket, probability, close the bracket. Probability is a probability corresponding to the normal distribution. It is required. So for the probability, we have 0.88493303. Okay, let's do the norm standard inverse function. Put the probability in here, and the result is 1.9999985. So this is the normal standard inverse function for the data. Okay, I think that's all for now. I hope you learned a lot that will help you in your study or anything else. So goodbye and see you in the next course.